Alright, so now you know the general process of inserting into a linked list. Let's just remind ourselves what exactly we're supposed to do. We're going to define an insert function that takes in a linked list, an item to insert, and an index. And what this first function is going to do is going to return a new linked list with the item inserted. Now, we're going to define the same function as well, but mutate the original linked list. So we're going to look at two special types of operations, but mainly doing the same thing. So let's define our insert function right here. So here's an example, and also just to make for simplicity's sake, we're going to assume that a valid index is given, and that just means that the index has to be greater than or equal to 0, and less than the length of the link. All right. So here we have an example where so in this one we want to actually return the linked list with the new link inserted. So, and then we have our item and we have our index. Okay, great. So remember, in our case 1 was that if the index was 0. What do? We just return link on the item and so now remember, in our first case we just basically put it at the front of the linked list, and it's really great because we just have that item and the rest of that linked list is our original linked list, and then we're done with that case. And then in the other case we just return link on the item and then insert the item into the rest of the linked list, because that basically, we don't do link of the item, we do link of link dot first. So because we're not inserting the item at the beginning, we're inserting it into somewhere in the rest of the linked list. So the way we take that idea is we do insert on the length of rest, and we have the same item, and then once we progress through the linked list, we now insert at the index -1 position. And now let's test this function just to make sure it works. And it does. Okay. Now, mutating this linked list is going to be a little more tricky because our first case is a little harder to visualize. But what we're going to do is it's the same first case, that the index is 0. So how do we mutate a linked list so that we insert an item at the front? Well, basically what we need to do is we need basically the link.rest is going to be, so our link.rest is going to be the link. But one thing we can do is we can't do this, because what that means is the rest of, so if we look at this example right now, what it's going to do is it's going to say the rest of this link is going to point to itself, and that's actually going to give it a circular structure, and that's not good, because when I go to, so let's actually do an example of this in the command prompt so you can see what happens when I do this. So so I'm just going to do python-i video 20, and so what we're going to do is I'm going to define my link as before. And so now what I'm going to say is the link.rest is equal to link. Watch the crazy madness that happens. So my link.first is going to be 1 still, okay? And then if I do link.rest.first, I get 2. Oh no, I should get 2, but I get 1. Because the link.rest ends up being the link. So no matter what, even if I do this like 1,000 times, so let's go crazy on this for a second. .rest, 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 .rest. First, it's still going to give me 1 because it's a cycle. It's a cycle. I can't get out of it. So this is why I can't do this. Like, this would be nice if I could do that, but it doesn't work. And it's because, so I strongly encourage you to draw the linked list out and see what happens when I do something like this. You'll see why it's a circle. It basically goes in a circle and you can't get out of it. So this is a terrible idea. All right. So we got to figure out a way to so the point is we want to still find a way to get a representation of the link itself. So what we can do is we can actually make a copy of it. So we can just create a new linked list here and assign it to the rest. So link.first. So this is basically the linked list. And so now we're still mutating the original linked list because we're changing the attribute. And then the link.first of this one is going to equal the item that we want. Alright, so now that we've finished with the first case, the second case is actually not too bad because we just end up calling insert mutate on the rest of the linked list. And notice I'm not returning anything or creating any new linked list because I want to basically mutate the linked list. So, and then remember, when we insert on the rest of the linked list, we're really inserting at the index -1th position. Same idea from the previous example. So now let's test this. I think this should work. So Python. Oh wait, Python. So yeah, it works. Great. Awesome. So this is how we basically insert into a linked list by mutation. Notice that we're actually physically changing the attributes and we're not returning anything, and so the hardest thing in this example is to notice that you can't do link.rest is equal to link. So that's something you might not have known, but it's really interesting that because it creates a cycle. So the way to prevent that is you have to basically make an entire copy of the linked list and just bind the rest of that to that linked list. Okay, now let's go into some more big ideas. So what we've seen is we've actually just seen the difference between destructive versus non-destructive functions. And so what does that mean? Basically, this right here is a non-destructive function because notice that when I define a linked list and I insert into something, I get something new, but my original linked list is untouched. So it's still that. But in the next example, my original linked list gets changed permanently. So what that means is basically this was a destructive method because it permanently changed the linked list I had, whereas the other one was a non-destructive method. And destructive methods are known for its mutation and the fact that we actually physically change the attributes of the linked list. But non-destructive methods, you don't touch anything with the attributes, you just create something new. Okay, so that's basically that. And now I want to just give you a big picture look at linked lists versus Python lists because this is a very important topic. Why do we use linked lists? This is where I'm going into that type of the purpose of what I've just talked about essentially. So linked lists are pretty good for inserting an item, in them. So what that basically means is because you can insert them so easily by just changing the pointers here and there, you don't have to do anything else. But inserting something into a Python list is pretty slow because let's say I want to insert at the second index right here. I have to shift this left and I have to shift this right. That's when we get big lists, that's a lot of operations because you have to physically move everything over. So in the linked list though, you can just search for the right position and just physically change a pointer here and pointer there, and you're done. And also, when you insert into a front of a Python list, you have to shift everything back. But inserting into a front here, you just make a new node and make the pointer of the rest of that to this. It's simple. So that's why inserting an item into a linked list is pretty fast. Turns out that deleting is also pretty fast in linked lists. But what we haven't talked about deletion operations. That's something we'll talk about later. But now, one thing that the Python list is better at is it's better at getting items. And why is that? Because it already has a notion of the index. So it stores absolute positions, whereas the linked list stores relative positions. So this has no notion of an index, so you actually have to search the linked list until you get to a particular index before you can find the element at it. So now then this leads us to why do we use linked lists? And the main reason is it has efficient insert operations and efficient delete operations, and also a huge thing about linked lists is they allow easy implementation of other data structures. And storing relative positions can also be pretty useful in some particular applications. So, you might be like, what applications? This doesn't seem applicable to anything, right? So it seems like I'm going about a bunch of garbage, but really, linked lists are immensely useful in technology today. And let me actually show you some examples, some pretty practical examples of this. So one example is the Windows Photo Viewer. Turns out that this is hidden, I'm sure there are not that many people out there that know this, but this is probably implemented by a linked list because what you can do is you can go right. So this literally says next. So you're going to the next one. No, so if we think of these images as items in a linked list, you're going to the next item. So oops, that's just something random. But yeah, you're going to the previous item, and then you're going previous item after that. And so yeah, this is how a Python linked list works because we can go to previous and we can also go to next. Now we haven't talked about how we go to something previous, but there's actually a special linked list that's called a doubly linked list where you can get you can go backwards and forward. So that's pretty cool. Well, that's something we'll talk about actually in the second part of this course, the data structures and algorithms class. So anyway, that's one application. Another application is with text editors, and Google Docs is one of the best text editors out there. So let's take a look at how that works. So why would Google Documents use a linked list? Well, turns out that every time I put a character, I'm inserting something into this linked list, right? And so also, when I go left and right, I'm moving my position in the linked list. So that the cursor is like a pointer in the linked list. And if I go right, I'm going to the next item. If I'm going left, I'm going to the previous item. So it turns out that linked lists are immensely useful to this type of application. And actually, I'm saying this because in my CS61B class, which was the data structures and algorithms class I took at Berkeley, one of our huge projects for the year was we had to build our very own text editor from scratch. So this was a really hard project, but it was a lot easier if we used a linked list. So, and that's why data structures is so important, because if you pick the right one, it just makes your life a lot easier. Some people in our CS61B class used an array, what's called an array list in Java, which is like a Python list, and they had a miserable time because it just made the entire project much harder to do. So that's why linked lists are pretty useful. They're used in also a whole variety of other applications, but these are just two of the ones I thought of off the top of my head. So anyway, I hope you really see the importance of linked lists, and understanding data structures will make you as a programmer overall much better, because you will be able to understand in what situation do I use a particular data structure to make my code as efficient as possible. Because at the end of the day, we want to make things efficient and we want to make them usable in the real world. So anyway, that's all I have for today. Thanks for watching.